All right, here's my week 6 Iron Chef Challenge. Basically, this week what we have is a DC motor that we're operating, and we're going to be doing that using an ultrasonic sensor for control. And actually, you can kind of see it works because when I point to it, it gets the motor going. So there's a little bit of complexity in the circuit here. So let's take a quick tour of what's going on. First off, you'll notice that I have a separate power supply over here. That's the power supply that actually runs the motor. It's on a separate circuit from the power that is actually running the Arduino, which is running off of the computer power. However, I have tied those together down here on their ground, so both of those sources of power have a common ground to them, so that's pretty important. And I really want to, you really need to be able to switch the power to the motor without actually having the power running through the same circuits, because there's a larger power demand for the motor, which can cause problems on the Arduino board if we try to run that much current through it, because they're not really designed for that. So I guess the first thing to do maybe is to talk about how the motor is controlled. And what I've opted to do is to use the H-bridge integrated circuit chip here, which is in the middle of the board. And in order to use that, I have it powered from in a couple of places here, and I have a couple of leads that are actually the outputs that go to the motor that I have put on my little improvised motor stand over here. And so basically when I get this thing going, it puts out the power through these two pins, the black and the red wire here, activating the motor. What determines whether that happens or not is basically in part whether there's a signal over here from this, but also these two buttons here. This button over here is set up on this pin right here through the Arduino, which basically turns the power to the motor on and off, so I can control that directly here. And this button actually causes it to reverse. And both of those come over to the Arduino as inputs, which then trigger an output over here to the H-bridge IC chip, basically controlling whether it's on or off, and whether we have direction flow there. And that's all pretty clear, I think, in the circuit diagram and in the coding itself, how that all works. It's a little complicated how it's laid up on the pins here, but again, all of that is outlined in the circuit diagram. So that's what actually controls the motor. And of course, the integrated circuit chip has a lot of transistors built into it that allows us to do that switching, and also allows us to isolate that power from the 9-volt battery without getting it back into the Arduino. So that's how the motor is controlled. And the way that I give input to the motor on how fast it should go is by using this right here, which is an ultrasonic sensor. Fairly simple setup there. I have power and ground attached to the outside there, and then I have two pins that are activated. One of those pins is for initiating a signal outward, and the other pin is for receiving that signal back. And the amount of time that it takes for the signal to come back, it can then be used based on the speed of sound to calculate the distance an object is from the two sensors. Pretty sophisticated, but pretty cool. As I mentioned in my blog, there are lots of circuits built into this IC chip, and if you look on the back of the ultrasonic sensor as well, quite a few circuits there, so, and chips as well. So it's pretty sophisticated, but as I mentioned as well in the blog, fairly fairly opaque in terms of what all this circuitry does, unless you really dig into what's going on in that IC chip and on the IC chips on the ultrasonic sensor. But let's get to exactly how this works. So right now I have my zoetrope off of it here so that we can kind of see the motor activity, because once we put that on, we're going to have a bit of difficulty. So I have a little distance target over here, and what I'm going to do is move that until we get some motor action. We can start hearing it trying to move, but it's got to get things going a little bit. So I bring it a little closer, and then it gets going, and then I can, once it gets going, I can kind of move it around, speed it up by putting it very close, slow it down by moving it away. And you can kind of hear it in the whining of the signal there as well inside the motor. And this is being basically pulse wave modulated, so a lot of switching on and off through digital pins there. So I can control that. The other things I control, as I mentioned, I can turn the power off here by hitting this switch over here, and I can turn it back on. And that momentary switch basically sends a signal that goes into the coating and ultimately back to the IC circuit to tell the motor whether it should be on or off. I can turn it off, and then I can press this button right here, which will reverse its direction. So when it starts back up, now it will go the other direction. I can also, by the way, do that on the fly and change directions. That's probably not the best practice to do that on the fly. Kind of gets things swinging pretty fast, and it all needs a little help getting going. There's a bit of tuning that obviously could be done, because depending upon the load of the motor, or whether you're in the startup part of the motor or in continuous operation, there's a different amount of power that's required to get it going. Often motors will have some sort of a capacitor to kind of kick it off in the beginning. I know this because I've paid several $100s for large capacitors to make my air conditioner compressor motor kick off, and that thing seems to go out about every other year, and they're quite expensive, quite large capacitors. At any rate, we're not quite that sophisticated yet, so this is about as good as it gets. Okay, so let's kind of look at this in action. I'm going to turn it off. I'm going to put my zoetrope on here. Try not to get it torqued too much at first. Let's see if we can actually see anything here. And then I'm going to turn my power on and let it get going. You might have to get a little closer to get it going. Make an adjustment, and you can kind of see the I think you can kind of see the flower in there. A little fast. I can pull this back, slow it down a bit so we get a little bit better image. Ooh, like I said, a little bit of tuning might be necessary to get everything to work absolutely perfectly with this motor. That's a lot of load that I have on that motor right now, and it doesn't like it when it gets to the edge. So I can then come back over here and turn it off. I can press my my little switch direction button. I can turn it back on. And now as I bring it closer, it's going to spin the other way. And we can see the flower going the other way in our image here. So kind of a fun project. I'm not sure how practical it is to have an ultrasonic sensor to make a zoetrope work, but hey, it was something to do and it was kind of fun. So we gave it a go. Clearly there are lots of opportunities to utilize ultrasonic sensors to do things with motors. That's kind of one of the fundamental things that you'll see in robotics. But At any rate, I thought I was pleased. It worked pretty well. As I mentioned in my blog, I did not really get to do my extension, and you can read about that and hopefully have a chuckle. It was met with a little bit of tongue in cheek, but it also was something I really was trying to do just for fun. At any rate, that's it for this week. I've enjoyed it. Hope you enjoy looking at this and get something out of it. So we'll see you about. Have a good week.